Find the set of solutions of this rational inequality. You want to find all the x such that this expression gives greater or equal to 0. Let's think first when this expression is equal to 0. The only way of this expression to be equal to 0 is that the numerator, this expression, is equal to 0. Then you solve it studying the cases where this expression gives equal to 0. And you say, one possibility, x equal 1. The other, x equal minus 2. The other, x equal 3. Then you have now all the solutions for which this inequality is equal to 0. Then let's think about the case when this expression is greater than 0. It means positive. And you say, those are multiplications. For this to be greater than 0 or positive, you need a combination of possibilities. We use, for a moment, the symbol plus, not as a sign, but indicating that something is positive. Now, it's not always, but to write short. Then, you want this to be positive. But you already know this power to be 0 or positive. But the case 0, we already studied it, Then positive. This is always positive or 0. But 0, we are not studying the case. The case 0 is already studied. When this is not 0, the even powers of non-zero expression or numbers is positive. Then this is always 0 or positive. But in this case, positive always. Because 0 is not the case that we are studying now. This one, the same. And more important, cannot be 0 because this is a divisor. Then it is positive or greater than 0. What about this? This, and this. I mean, to study the case where this is greater than 0, I prefer to study all the critical points of these expressions that I'm going to call A, B, C, D. Because the other are, as I said, always 0 or positive. They don't change the result. It depends on A, the possibility of positivity or negative depends on A, all power of this B, all power, C, odd power and this the odd power. Let's study then the expressions like 1 minus x to the 7, x minus 3 to the 7 divided by s plus 1 to the 5 and x plus 6. Remember, the others don't contribute to the sign of the expression. For the others, they are positive. Then, let's study what I'm going to call the critical points. Draw a line and write this x equal 1 makes this expression 0. Then write down the 1 in the line. Here is the 1. Now the other value that makes this expression 0, which is the 3. And then the minus 1. And then the minus 6. My God. And no more. So, let's think what happened. What cases arise for this expression when you move to the line at top of here. The values of x may be less than minus 6. Between minus 6 and minus 1. Between minus 1 and 1. Between 1 and 3. And greater than 3. Let's see what happened with this expression here. Let's call it 1. Don't repeat this, It's here. What happened here with the expression s plus 6? S plus 6 to the left of minus 6. This expression is negative. Here is 0, but it's not the case we are studying. Between minus 6 and minus 1, in this region, as example, the number minus 5 plus 6 gives positive, Then, after, for values greater than minus 6, this expression is positive. Now, what happened with s plus 1? At minus 1, s plus 1 gives 0. To the left of minus 1, s plus 1 is negative. See the case as minus 2 plus 1 is minus 1, negative. Here it is 0, and to the left, in this case, is negative. Now, to the right, for all the other values, s plus 1 is positive. Let's study this root 1 that corresponds to this expression. What happened with, of course, the sign of the powers of the odd powers, we design a design of x plus 1. This is to the 1. And what about the 0 here that corresponds to 1 minus x? When x equal 1, it gives 0, 1 minus x to the 7. What happened with the values of 1 minus x when you are to the left of 1 or negative numbers? Of course, when you subtract a negative number, it gives positive. Then those are positive. Think about carefully. And to the right of 1, this is greater than 1, to the right of 1, then gives negative. Now gives negative. And continue with the one that we have to study, the last one. What happened with x minus 3, which is the same that thinking about if x minus 3 to the 7 is positive or negative. Let's think about x minus 3. Of course, when x equal to 3, here it gives 0. And when x is greater than 3, it gives positive. Greater than 3, Positive, otherwise negative. Then all the possibilities of these expressions, see what happened when x is less than minus 6. This gives the sign plus, this product, times plus is plus, times minus is minus. In this region, all the operations here together, multiplying and dividing, follow the law of signs of multiplication that are similar to the division when they are mixed. Now, here gives 0 because of this value, but we are thinking about when this expression is positive, and here is negative. Now, this expression here, the expression 1, this gives 0 here, and here plus times minus minus, plus plus minus still, plus times minus is minus, that minus times plus is minus, still minus, and times minus is plus, positive. Here, because of this 0, gives 0, the product, but we are studying the case when they are positive, Now, or negative, but in our case, is positive. Now, here, the sign will be, or the expression will be plus times plus minus, negative. And here, plus times 0 gives 0. And here, plus times minus is minus, times minus is plus. Here gives 0 because of this expression here. And here gives plus times minus is minus, times plus is minus, still minus. Then, we are trying to see when this is positive or 0, But the case 0, we are already studying, but the case equal to 0, you already study it. In the case x is equal to 1, here this 0, here gives 0, because of this numerator, and x equal to 3, when it gives 0 also, on the other, this divisor cannot be 0, because x should be different from -1 and x different from -6, really. So in reality, this expression here for -6 doesn't exist. Doesn't exist because of the divisor, and for -1 doesn't exist, doesn't exist because of the divisor and doesn't exist. But here, because these roots are of the numerator, the expression gives 0, and the same at x equal 3. Then, we are studying the case x greater or equal to 0. Then we see, then we can check here, this is greater than 0. In this, so this here doesn't exist. This here doesn't exist. Now we are in a part of the solution. This is less than 0, then it's not part of the solution. Also this part. And here 0, because it says that can be 0, this is part of the solution. X equal 1, see? X equal 1. And here also for x equal 3. And this is greater than 0, and then this is part of the solution also. All these lines show me solutions, but they are asking about the x, They are asking about the x. Then you have to take a look here. Those are the x between, in the interval, in the open interval, -6, -1. Those are the x. This is an interval this is a closed interval, because the 1 is part of the solution and the 3 also. Then this is the interval 1, all the numbers between 1 and 3, including all the x between 1 and 3, including the extremes or the ends, 1 and 3. And no more, because this is not positive or 0. I have to make here a correction. Those points, at those points, the inequality doesn't exist, Then -1 is not part of the solution, which is true over here. -6 is not, which is true over here. But I forgot this rule because this power was even, and this root is x equal 4 divided by 3, 1 point something. one number someplace here, with this 4/3. So this interval I have to split this interval and say that the solution is -6 -1, that is here, union, and split this interval this way. 1, 2, 4/3, open because the function doesn't exist here, union, 4/3, 3, and then close here because the expression gives 0 over here. This is up to now my solution. You can check that. You can do it by yourself. You can try to find mistakes. But I'm sure that without this method of the table and critical values, it's much more difficult to find the real solution to this inequality.